Okay, students, here we go with the first video in which I will just discuss a little bit of architecture of 8086. The first look should be of the registers of 8086 because the CPU, the microprocessor, is everything in the programming of assembly language. So if you look at this video, actually this picture, this is the registers what we are having with the 8086. On the top you could see we have registers like AHAL. This is actually a 16-bit long register called AX, which can be used as a 8-bit lower half and the 8-bit upper half. So we call it as a AL and AH. It's actually what we call as the accumulator. And in addition to the accumulator, we have 3 more 16-bit registers. That means 2 bytes. But they can be used as byte register or as a word register, meaning it can act as a DX, for example, or it can DX as a word. That means 16 bits, or as a 2 bytes. One is the lower one is the upper one. So we have 4 here registers, 16 bits long: AX, BX, CX, and DX. And then these are actually the general purpose registers. That means we can use them for many things. But this AX is a special one in it because this accumulator is used not only for the general purposes but sometimes as a special purposes. For example, if you want to do multiplication or divisions, at that time we have a one operand in the AX. The multiplication always works on the AX, so we need to keep our one operand which we want to divide or multiply in the AX. Then on the lower half we have got the, as you could see, these are all 16 bits long, and as you can see here we are written 16 bits. So it is the SI, source index, destination index. Then we have base pointer, stack pointer, and IP is instruction pointer. They basically are used to store addresses. They can act as a pointers. Maybe you want to work with arrays in your program. At that time you load the offsets or the addresses of the bytes or memory locations where you want to put your data or whatever into the source index or destination index. Or we have the base pointers and stack pointers. The stack pointer, which you could see, is used to store the top of the stack, and instruction pointer IP also is used to store actually the addresses. It works actually with the code segment. It usually stores the offset of the code segment, which I will just tell you shortly. Here in the downside you could see we have 4 segment registers here: core segment, data segment, stack segment, and extra segment. These segment registers hold the address of the segments, because in 8086 the memory is segmentized. That means we have a 4 in the memory we have 4 segments. One is for the code, one is for data, one is for stack, one is for extra. Actually we have partitioned our memory into the 4 areas to store either their code, either the data, or for the stack, or extra means we use for some other purposes. Data means where we actually put in our variables or whatever. We want to create arrays, what we do in other languages. We want to create some variables, we'll put them in the data segment, or some messages to be printed or placed in data segment. And code segment is where you actually write your code. And the stack segment is where you put your stack. And stack is very important. If it's a function call or whatever, you have to use stack. Or you want to preserve your registers any time you want to preserve your registers because you're going to update them, but you want your previous values in the registers, so you better reserve your preserve or your registers on the stack. Then there is extra segment is used for many other purposes. This is at the discretion of the programmer to use the extra segment. So we have also the flag, the 16 1-bit flag. In total 16 flag register. It's a flag register. We have many flag registers like 0 flag, carry flag. They are set or reset actually, 1 or 0. They are actually used to check. Now, for example, you divide a number, and if the coefficient comes to be 0, 0 flag is set. Similarly, if you add two numbers and the carry is generated, and that carry flag is set. So these are used then for our decision purposes. For example, we want to go to some other part of a program and we will check if the carry flag is set or not. So it's like that. And then we have the ALU and control unit here, which will work together. Actually, this is not the complete picture of the 8086 microprocessor. This is only just the register shown. In fact, these here, these AX general purpose registers are placed in a one side called bus interface unit. If you open up a book maybe and you will look, they will be in a bus interface unit, and on the side it will have some prefetch queue, the registers which are actually used to prefetch the instructions. That means instructions which are going to be executed are actually queued in the 6 registers, so that the microprocessor works on them. And because microprocessor has to, this ALU for example you see here, has to work on the instructions, and those instructions are actually prefetched and put in the queue. And at this control unit actually generates signals from those instructions and give it to the ALU later on for the execution. So this is the basic register structure which I actually need in our assembly language, because most of the time I'm gonna use these general purpose registers or source indexes or destination indexes to store our addresses here, and we could use to store some data variables here, and then later on do some operations on these things. For example, we want to add two numbers. Well, maybe I put one number in the AX, then second number in the BX, then I'm going to add them, say add AX comma BX, write the mnemonics like that. That will add me AX and BX and store the result in the AX. So I could sometimes use only 8 bits, that means only AL, and sometimes I'm gonna use it a whole, like AX, that is 2 bytes, a word, or 16 bits. So that's all for now. Watch the next to keep pumping. Thank you.